Alright class, today we're talking about composite functions. The first thing I want to show you is, if you look at number 1, it's written as f and then like a circle and g of something. Now, last year you probably saw it more like this, f of g of x. These mean the same thing. It's good to know both of these because sometimes on standardized tests they show you the first version. You have to know that it is a composite where g is the input of f in this case. Okay. Alright, so now what we're going to do is we're going to look at how to find composite functions using a table. I'm going to do the first two with explanation, and then I'm going to let you guys pause the screen. So first thing I'm going to do is rewrite this. So this is f of, and then g of 1. So the first thing you want to do is work from the inside out. You want to find out what this input's going to be. So we need to figure out what g of 1 is. To do that, this is telling you that the x is 1. So when x is 1, g, the output is 0. So this whole thing then is going to turn into the number 0. So this becomes f of 0. Now 0 is your input. So now 0 is like your new x. Now that's your x. So when I go to 0 for x, I look at what f is because I want f this time. And I get that the final answer to the problem is 5. Okay, let's try that one again. F of g of 2. The first thing we have to find is the input, which is g of 2. So here's 2 over here. G would be negative 3. So now it's f of negative 3. And then when you look at f of negative 3, you go to negative 3, you look at f, then you get 11. Alright, if you guys are getting this, I want you to try to maybe pause the video and see if you can get the next 3 on your own. If you're still confused, let's keep going. So the first thing I have to do for this one is find out what g of 3 is. So I look at my table. My table, when x is 3, g is negative. Wait, what's going on here? Oh, I messed up. This is the different order. The different order. So really we're doing g of f of 3. I was like, that doesn't make sense. And that's why. So when we go to 3 for x, we want f, which is negative 1. So that means that this now becomes g of negative 1. And g of negative 1, if you go to negative 1 and find out what g is 0. So you should have gotten 0 for this one. Now we're doing g of g. G of 1 is 0. And then we need g of 0. So here's 0 for x. G is 1. And finally we're doing f of 3. Well, what is f of 3? Let's take a look. Here's 3. Here's f. It's negative 1. I should have known that. We did that a little earlier. Then we go to negative 1, and we want f. So that is 7. So those should be the values. 5, 11, 0, 1, 7. Alright, now we're going to do it kind of the same way, except for with, well, the first two are with numbers. So what I'm going to do is, this is equal to f of g of 3. So the first thing we need to find is g of 3. I'm going to do it as separate steps. So g of 3 is equal to 2 times 3 squared, which is 18. So now this is going to replace that, because that is what g of 3 is. So now we're doing f of 18. F of 18 is 3 times 18 plus 1, which is 55. So the composite is 55. Alright, now we'll do it again. We have g of, and then the inside is f of negative 1. So the first thing we're doing again is f of negative 1. So I have to figure out what f of negative 1 is. You put that into f. Negative 3 plus 1 is negative 2. That is now my input into g. So g of negative 2. So we get 2 times negative 2 quantity squared. That's positive 4 times 2 is positive 8. For these ones, we are trying to put them, there's no numbers, so we are just going to leave that. We're going to just make it a composite together. So to do this, the outside one I write, but instead of x I leave brackets. So that was where x was. So that would be f normally. But instead of x, we're putting in g of x. So instead of x here, I'm going to put a 2x squared. So that's how that works. And then what we can do is simplify this a little bit and then make it 6x squared plus 1. Alright. Then we have g of f. So we have g of f of x. G is that. 2 something squared. That something is going to be 3x plus 1. Now, I'm not going to simplify that one, but you could FOIL it out and then multiply by 2. I just don't have time right now in the video, so I'm going to keep going. So this one we're sticking f into itself, kind of like Inception. I don't know if you guys saw that, a dream within a dream. A function within a function. I guess that's all composite functions, but it's its own this time. So we have 3 parentheses plus 1. And what am I sticking in for x? I'm sticking in itself 3x plus 1. So this is like the outside and the inside. They're the same. So we can simplify 9x plus 3 plus 1 is 9x plus 4. We can do the same thing with g. So g of x is 2 something, or 2x squared, but instead of x we're sticking g of x in, which is 2x squared. So to simplify that, that's 4x to the 4th times 2, which is 8x to the 4th. Okay. Okay, the last thing we're going to talk about is domain for functions. Thing that's important to note, the domain restrictions come from the final answer and the input. Those are the 2 things you have to look at for your domain restrictions. So what I do before I even start is I figure out what my domain restrictions are for the 2 pieces. So for this one, f of x is 1 over x. X cannot be 0 for that. G of x is x plus 2. That's no big deal. That's just a line, so that's all real numbers. Alright, so now we're going to do composites. F of g of x means I'm sticking g of x into f. So f is 1 over blank, and we're sticking g into there. So that's pretty much the answer, 1 over x plus 2. So you look at 2 things. You look at the input, g of x has no restrictions, it's all real numbers. Then we look at the final answer. If you look at the final answer, though, we would say that the domain is that x cannot equal -2. Okay? Let's flip it around and do g of f. So g is x plus 2, so instead I'm going to do that plus 2. We're going to put a 1 over x in. Now, if I want it as 2 separate pieces, you can leave it like that. Or you can combine it by using a common denominator. And if you do that, you get a 2x and a 1 on top all over x. Regardless, the domain, if you look, the final answer you can't be 0. The input you also can't be 0, so that's good. We're good there. The input is 1 over x. This is my favorite problem of the notes, because I like what it does with the domain, and people always mess this up. So we get 1 over, and then we're putting in itself. So this is a 1 over x. So hopefully you guys remember that when you are dividing by a fraction, you multiply by its reciprocal. So this becomes times x over 1, which basically is just x. Now if you look at that, you say, oh, x is fine by itself. It's just a line, y equals x. There are no domain restrictions. And that is true. There are no domain restrictions for just x. However, you have to look at what we input. We input f of x. And there is a domain restriction for f of x. The domain restriction is that x cannot be 0. The reason why that is that we couldn't get to this answer if our input was undefined. Alright, so if our input's undefined, we can't get our final answer. So we can't get a defined thing if x is 0 at the beginning, even though the final answer looks okay. G of x. So we get something plus 2, and that something is x plus 2. So this just goes to x plus 4. And if you look at this one, the final answer is fine because it's just x plus 4. There's no denominators, no square roots. And then over here, the input is also all real numbers, so for this one, the domain is all real numbers. Okay, so that's composite functions. We're going to start using inverses and one-to-ones next video. I hope you guys are having a good day.